dirt simple mechanical ventilator, what can service hundreds of patients at a time, made from three very simple components, tens of dozens of which are sitting on every industrial supply house's shelves the world over at this very moment. What are we waiting for? Well, like I said, I ain't no gynecologist, but I'll take a look. Gentlemen, welcome back to the shop in this forced furlough, unpaid mind, but hey, we're all pulling together. It's not like the powers that be, doctorbs and the politicians and the people on furlough from the government and all those cushy kind of municipal union jobs. It's not like they're getting paid, right? I'm doing my part. Do as you're ordered, like lambs to the slaughter. Staying home, staying the fuck away from other people, as is recommended. I'm busier than a dog with two dinks, and being home is actually fantastical because I get to knock some off the list and keeping the wife happy, if you know what I'm saying. You know, let me tell you, 9 months from now, baby wipes and diapers, you make a mint. I set to thinking there. I couldn't sleep last night, so I set to thinking. I saw the talking heads on the Confuser saying that what we're missing is ventilators. Now, ventilators, that's a technical problem, and technical problems, that's how we do. So that is an industrial bottleneck, apparently. They can't get enough ventilators. Now, whether or not that's just the party line, and that if we solve that bottleneck, they just move on to the next bottleneck, which, if you've worked in mining or heavy industry, essentially all you're doing is just hitting the next bottleneck until it's not economically viable to hit that next bottleneck, you know? So, but in any case, one thing I've been seeing from the open source community is a lot of hand ventilators turned into automagic ventilators. Now, that's great and all. However, if you have, say, a life-giving milkshake and you queue people up and they all get their milkshake, you make the milkshake, you give them the milkshake, and then they sip the milkshake, and then they're better. If you have a long enough queue, you no longer want to be making the milkshakes one by each. You'll want to make them in a big old jug, a big old bucket, and give everybody a long straw. So this is my idea, and fewer moving parts. A lot of these ventilators, what they're making, cobbled together, tons of moving parts. We don't want that. Fewer moving parts to keep it simple, stupid. I think it was either Ray Kroc or Weinstein said, make it only as simple as it needs to be, but no simpler. So the simplest thing I can come up with, and I'm tapping into Cunningham's law, in that the way to get a good answer on the internet is not to post a question, but to post the wrong answer. So all of the components on here, completely ubiquitous throughout industry and very easily maintained by anyone with a modicum of technical knowledge. So you move on here, we get ventilation down. Well, now we're into staffing issues where we need more people technical people within 30 minutes of running this system will have it down. You have them volunteer as long as, you have protocols in place in the hospital or the field tent or the parachute inflated with Herman Nelson. You're chasing bottlenecks at this point. So what we do is we have an air compressor, and we want a special kind of air compressor, a scroll compressor, because there's no oil in the airstream. So if you have a screw compressor, then you have to remove the oil from the flow. You don't want that going into people's lungs. You could also do one of those, reciprocal if you needed to. So you get a big G's-less receptacle at 120 PSI. Now, that's far too much for a human lung. So you have a pressure-reducing valve. A pressure-reducing valve, of course, as opposed to a relief valve, it reduces the pressure downstream. So you set this up to whatever the lung capacity is, 30 centimeters of H2O pressure. That's about half a pissy. Now, all this information I gleaned came from the WHO website. There's a PDF on how to treat the victims of this virus if they have complications and they need to be put on respirators. Also, the respirators generally they're going to be using are not the CPAP type that just fit over the face. They are going to be intubated And there's two apparent ways to do well. There's a number of ways. They can go through your nose, they can go through your mouth and down in your throat, up high, and they can go down. They got that J-hook looking thing that goes right in there. You got to be sedated. It's fucking nasty. And they also have an intubator that goes down, and then a bag inflates below your vocal cords. So that seems pretty uncomfortable to me, but that bag inflating, that also needs some air. Here's the thing, what's missing with most of the DIY solutions, what I've seen, is that there's no additional oxygen. If the patient is that bad, they need additional oxygen. So this system allows you to have hundreds of patients hooked up very quickly and have additional oxygen. As I was saying, we have a pressure reducing valve down to 0.5 PSI. We have a relief valve. We don't need that relief valve unless we're intubating, because the mask, of course, the CPAP mask will just come off the face if the pressure spikes. We have a flow meter here for closed loop control. You wouldn't actually need this if push comes to shove. So what we have is a bog standard zero pressure solenoid valve. Now, a zero pressure valve is special. It's a little bit special. You can get those ASCO Red Hat valves that are zero pressure from Crackmaster Car. I'll pull out the Bible and show you. In Tom Sachs we trust. I have very few items I'm particularly attached to, but this might be... you'll excuse me for partaking in some McMasturbation. Also good for sitting at home during these troubling times. I don't think it's the stuff you're prepared for what's going to get you. It's the stuff you're not prepared for what's going to get you. We're reasonably prepared. Reasonably. Now, of course, we could go through the index. Yeah, we're going to have to go through the index. It's 4,000 pages of the finest industrial strata. Oh, conveniently, we'll need these for later. Bong plugs. After the commenters get through with me. If they can declutch the pearls for long enough. That's what I'm talking about. This needs at least 5 PSI required drop across the valve. Now, 5 PSI, blow somebody's lungs up like a balloon. What you need, none required. Pressure drop across the valve, none required. As I said, a ubiquitous solenoid operated, normally closed valve that allows this 0.5 PSI to inflate a bag at the same time, because when you're being intubated, a lot of times you need oxygen. You're not just getting breathing air, you're getting additional oxygen because you're going blue, essentially. You can't breathe well enough. This is the kicker. You need to have supplemental oxygen. And commercially available medical ventilators, of course, recirculate the air to not waste too much oxygen. They pull out the CO2 and recycle that oxygen so you're not wasting it. That's one of the drawbacks here, is that you will be wasting a lot of oxygen, because what you're doing is you're just using the same circuit on the oxygen side. Now, we have a flow meter in here. We could drive it by PLC or input it to a PLC. I prefer PLCs because they're industry hardened, whereas an Arduino or a Raspberry Pi, they tend to be glitchy. I'm just throwing it out there. We've all run one of those things and you don't know why it's not working, but you reset it and it works fine. Well, if you got to reset it and there's a human on the other end of this, humans do not reset all that well. So we have the same valve arrangement on this side, and we could use a closed loop flow meter to input that. We could also use it open loop because we know that the temperature is going to be reasonably constant. The PRV is going to be reasonably constant. So depending on the timing, if you just cycle this for a second, you know you will get a defined amount of fluid through that valve, mix into a low pressure bag, and then once it's mixed with the air, goes into the patient's lung with a directional control valve. This would be tougher to find that's zero pressure drop, but I'm sure they're out there. And then what you would do is you would inflate the bag for a certain amount of time, inflate the lungs, and then go in reverse and have this go directly to exhaust, to atmosphere. So you would inflate the bag and then deflate the bag. Here's the proof of concept arrangement. PRV, industrial pressure reducing valve, good name brand, not janky. And a janky valve, what will not work for us, as indicated by the lowest pressure rating, 1.5 bar. That's 20 psi, blow you right up like a balloon. And of course the valve does not exhaust, so I'm using my fingy to supplement that exhaust valve. If this works, this is something that any industrial anybody really could make. An electrical supplier, plumbing supplier, HVAC supplier, anybody could make and babysit this system. We got the patient intubated in this cutting edge medical sciencery. You can tell by the stainless. Now very careful in here. We're going to increase the pressure. There we have flow. I'll close this and the bag will inflate. Drop it and the bag will deflate. A little weight isn't doing it for me. It's inflating and floating up, and then it doesn't retract, or it doesn't expel the gas. What would you call that? Exhume, expectorate, breathe out, exhale. Jesus rice. It's like this guy's just some random bumblefuck in his own garage. Inflate, oh. Overinflated the lung. I guess that, well, no, this would be a PC, pressure comp. No, PC. Pressure, or PV. I don't know, there's a term for it. There's AC and PV. So this would be pressure ventilated. You wouldn't get anything over half a PSI. There we go. Huh? Easy peasy lemon squeezy. Yeah, so ventilator of last resort. Couple of valves. Compressor in a tank. Now we have a patient with a slightly less compliant lung, maybe older. Heavy smoker. Lives in pollution. Still working. Get a different angle on that. If the only option was this or death, would you take it? These could be manufactured quick, fast, in a hurry too, for hundreds of patients. Of course, you will run into a bottleneck of what's currently in the supply chain, being that the supply chain has essentially shut down. Still, I bet you there is a lot of valves kicking around industrial supply warehouses. Thanks for watching. You got any other ideas? Go ahead and put them in down below me in the doobly-doo. Thanks for watching. Keep your dick in a vice.